Example 7. Given that x and y are random variables, x is normally distributed with mean of 100 and variance of 16, and y is normally distributed with mean of 90 and variance of 20, find the probability that a randomly chosen x is smaller than a randomly chosen y. So I hope that you guys are all fairly okay with the idea that if x is less than y, that's essentially the same thing as saying that x minus y is got to be less than 0. So if I ask for the probability that x is less than y, that's the same thing as asking the probability x minus y is less than 0. In particular, what am I looking for? Well, I want to know what is the distribution of x minus y, and I can tell you that it's a normal distribution, but we knew because we can add or subtract normal distributions the same way. And the distribution of it, the mean, is going to be the mean of x minus the mean of y, as we'd expect. So the mean is going to be 10. But what about the variance? Well, to find the variance, we take the variance of x and we add the variance of y. So the variance of this distribution will be 16 plus 20 will be 36. Why do we have to add the variance? Well, because you've got two distributions that you're combining together. The spread is still going to be very, very big. You've done nothing to reduce the spread by subtracting one from the other. So that means our measure of spread, our variance, should actually get bigger, not get smaller. So just intuitively, you should be able to use that type of reasoning to understand why it needs to get bigger and not smaller. So that lets us ask the question, what is the probability that x minus y is less than 0? And we can just key this into our graphing calculator now. So the probability that x minus y is less than 0, we go to distribution. But we get out of our polysimiles first, sorry. We go to distribution. We want the normal CDF. And let me just check how this works again, sorry. Again, this is the old, you shouldn't be seeing the screen. You should have the new version. So what do we key in? We key in our lower bound, which is minus infinity, so minus 999999999, something like that. Then we key in our upper bound, which was 0. So if we look just back here, this is really the same thing as saying the probability that minus infinity is less than x minus y is less than 0. So we're looking for things between minus infinity and 0. So that's why we've keyed in those two values. Then our mean is what? Well, our mean was 10, wasn't it? And our variance was 36. So we have to be careful here. The variance was 36, but the GC asks for the standard deviation. The standard deviation is the square root of the variance is just 6. So we key this in, and there's an error in my syntax. So let me just figure out what's gone wrong. So it didn't take me too long to find out the error in my syntax. I just used a simple use the goto command, and I'd pushed minus instead of negative. So just make sure that you don't make the same mistakes that I do. And we find that the answer is negative is 0.4779 or 0.478 to three significant figures. So this is 0.0478 to 3 SF. Part 2, what do we have to do? In part 2, we're asked to find the probability that x plus 3y is bigger than 400. So if I know the distribution of y, what's the distribution of 3y? Well, as we might expect, to find the mean, we multiply it by 3. So 90 times 3 will be 270. And to find the variance, well, we don't multiply it by 3. We instead multiply it by 3 squared, because remember, this is the standard deviation squared. So there's this extra squared term that appears. So we take 20 times 9. 20 times 9 is 180. So what about the distribution for x plus 3y? Well, again, it's going to be normally distributed. And again, we just add the two means together. So we get the mean of 370. And we can also add the variances together. So we get a variance of 196. So we go to our calculator again. Oh, so what are we asked to do, sir? We're asked to find the probability that x plus 3y is bigger than 400, well, this is 1 minus the probability that... Actually, no, I don't need to do that. I can take care of this on my GC. So remember, this is equal essentially to the probability that 400 is less than x plus 3y is less than positive infinity. And the number that we get for that, keying it in with those bounds, so again, distribution, normal CDF, and our lower bound was 400, our upper bound was infinity, so I'm just going to put some 9s in there. Our mean was 370, right? And our standard deviation is what? Well, it's the square root of 196. And so we get the answer 0.01606, or rather, to three significant figures, this is 0.0161. Oops. And that is example 7. Any questions, please just post in the comment section below.